Hi, everyone. I guess we can begin. Thank you so much for coming to this session. I'm happy to see you all. I see that there is also my VP in the room, so no pressure. My name is ALINA, and in this session today, we will talk about GraalVM, and more specifically, this ahead-of-time native image compilation part of GraalVM, where you can take a Java application, compile it ahead of time, and have a native executable in the end that will be very fast and very small and will work very efficiently. So let's go, and let's start with the quick intro. So this is my name. This is my handle on all kinds of social media. If you want to follow up or ask a question or just have some feedback about GraalVM, you can find me by this name. And I'm a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle, where we're creating brand new bleeding edge technology projects. So we're really happy to be working there. I love open source and communities. That's why I love coming to conferences and getting to talk to people in person. And I love both programming and natural languages. And you can find me by this photo and this name if you want to follow up or ask a question. So let's go ahead and let's talk about GraalVM. First thing I want to try to ask you, how many of you have tried building something with GraalVM? Okay, so let's say half of the room. I'm very happy to see how this number gets bigger and bigger over the years. And I hope that I can convince maybe a few more of you to try to do something with GraalVM by the end of this session. So GraalVM, just to develop the same language, GraalVM is a JDK in the first place. So it's a normal JDK as you would have Oracle JDK, OpenJDK, whatever is the JDK of your choice. And we just add on top of it. So we're not taking pretty much anything away from it. We just add on top. And the things that we add on top is this native image ahead of time compilation. We add our own great JIT compiler. So you can also run applications on GraalVM as a JDK. And we add polyglot capabilities, but the base itself is just a normal Oracle or OpenJDK. We are not taking anything away from it. And the way how GraalVM is different from pretty much any other JDK distro out there is that with GraalVM, you get this choice how you can run your Java applications. So you can run them on the JVM with a Java command, and then you get all your tooling, libraries, very easy migration path. And as a benefit, you get this brand new GraalVM JIT compiler that is very good, brand new, a lot of unique optimizations that are only in GraalVM JIT. So even by migrating to GraalVM as a JIT, you'll already see good performance improvements, maybe 10, 15, 20%. And we also have native image, and this is brand new for the Java ecosystem, where we compile applications ahead of time into native executables. So one thing that I would like you to take from this slide is that with GraalVM, you do get this choice. It's not one or another, but you get to choose how you want to run your applications on GraalVM. And I also want to show you this slide. So I mentioned that I work at Labs, and at Labs, we do a lot of research projects, and GraalVM has been one of such research projects for a long time. So you can see in 2011, Thomas Wirtinger joined Labs and started working on GraalVM. So now it's 2024, so it's been 13 years now. And I like showing this slide because A, it's beautiful, and I'm proud of our slide design. But also, I think it's cool how many of those, important milestones we had over the years, where we had some new partnerships, new integrations, new customers. And there are a lot of cool things there, but I would like to highlight some of my favorites. So in 2019, we went GA with our first production release. So it was, 5 years ago now? And then in 2020, Alibaba, it was our first big kind of user of GraalVM native image specifically. So it might seem to you that native image, this ahead-of-time compilation, is very new, revolutionary, scary, and in a way it is. But also there are people who have been using it in production happily under a huge load. Alibaba, I mean, you can imagine what kind of load is that. And that has been going on for 4 years, and they are very happy with the production qualities of native image. And I love Spring and Spring Boot. So I was very happy to see in 2021 when Spring Native went live. So since 2021, you could have been building Spring applications natively with GraalVM, and then it went even GA in 2022, I think. So yeah, a lot of exciting steps along the way and a lot of history that we have to share with you. But let's talk about native image and how it's possible to even take something so dynamic as Java and Java application and compile it ahead of time into a native executable. So when you first run your native image command and you give it your application, and as an input, it takes bytecode. So it has to be either a jar or a class file. So what will happen next is that native image will look at your application starting from its main entry point, and it will try to find all the reachable code paths. So it will try to understand what the application is supposed to be doing and have this full picture in their head. So it can then eliminate everything else, everything that you don't need. So just to produce the small, compact, native executable. And this applies to your own what we call user code, so the code that you wrote yourself, but the same also applies to your dependencies, even the JDK classes. So we will analyze everything there is in your project, and then we will eliminate things that you're not actively using, so that at runtime, you only have things that you need. And that is one big part of native image, but another big part that native image architect likes to mention always to us is that compilation is one part of the story, but also we are doing heap snapshotting. So we will like preview and snapshot a part of your heap. So you can start with pre-populated heap at runtime, and this way you don't need to allocate objects anymore at runtime, and you can start much, much faster. So you start with this pre-populated heap and with your machine code. And as a output of this process, you get a native executable that is specific to the operating system and architecture. And yes, since it's a native application, it doesn't need a JVM to run. So the whole point of doing all this is to shift all of that work of analyzing, compiling, optimizing your application from runtime to build time. Because we think that many applications are started way more often than they are built. So it kind of makes sense to do all of that work once at build time, and then you can start much faster every single time when you have to, but you don't need to spend time at runtime and importantly spend resources at runtime optimizing and compiling your application. And if you have heard anything about native image, you might have heard that applications built with GraalVM start fast, and often people focus on this one part of GraalVM. And indeed, it is impressive, and we will see in a couple of minutes how fast your application can start with GraalVM and native image. But sometimes people will say to that, I have a long-running application. So I have an application that I deploy, and then it runs for, I don't know, hours, days, and weeks. So maybe I don't care about startup that much. And I agree with you that it's not always that startup is important. It's important for serverless, it's important for microservices, but not for every Java application out there. But luckily, this is not where the benefits of native image end. So in addition to startup, since we are doing all of that analyzing, compiling, optimizing code at build time, we don't have to do it anymore at runtime. And this means that we don't need that much CPU and memory anymore because we are not loading classes, we are not profiling, we are not compiling. It all already happened at build time. Another interesting part of native image, I will not be doing this in this session, but if you ever run your application on a JVM and native image and you collect information about the performance of your application, you will see that on the JVM, we all notice a bit of a warm-up curve. So initially you start your application and it takes a bit to warm up, but then when it does, when it optimizes your whole application, it gets really fast. With native image, this kind of performance, curve line is very stable because, again, everything is already optimized and compiled. And I like how the Spring people call this. They call it instant performance. So this means as soon as you start your application, it's on and it's available to go and do whatever it's supposed to do. It doesn't need to warm up anymore. So the performance profile is very stable over time. There is also additional interesting layer of improved security that native image adds on top of the JVM because of this closed world assumption and eliminating all the code that you don't need. And also with native image, you can produce very small binaries and very small container images, so you can deploy your application much faster and scale it much faster. And again, now in 2024, it's very easy to build applications with GraalVM and native image because all those major frameworks in the Java ecosystem, all the cloud vendors have support for GraalVM native image. So whatever you use, especially if you start a new project now in 2024, it's very easy to build new apps with GraalVM. But maybe enough talking, and let's see some of that in action. So I want to start this by showing you a Spring Boot application. Let me just move this higher up and remove all of this. And no, but actually, let's look at the app. So I want to start with the native Spring Boot application. And at the base, there is a lot of stuff because I'll be showing it for other demos, but let's focus on the fact that this is a Spring Boot application. Here is my main class, and I also have this controller with one endpoint. So let's pretend this is all there is. Let's see if we can run this on GraalVM. So I mentioned a couple of times that GraalVM is a normal JDK. Let's see what we are running on. And here what I have is Oracle GraalVM for JDK 22. So this is the latest production-grade released version of GraalVM. Let's run this app. Let's maybe run this first on the JVM. Okay, it runs. And if we go to our endpoint and maybe close the things that we don't need, we see our endpoint, it's all working so good. But, you can see where this is heading, I think. So we are here to talk about GraalVM. So let's make it native. So maven p native compile. And this will now start my native image build. This will look scary for a second, but just because there is a lot of stuff on the class path, so this thing. But now it's actually getting to the native image generation part of it. And for me, the most interesting part of the native image build is this first stage when it tells me all the info about my environment and my build. So for example, it tells me that indeed I'm using Oracle GraalVM for JDK22. I'm not doing any additional performance optimizations because for the sake of this demo, I don't need them. I'm just using plain serial GC. And it also walks me through all the steps, for example, how much memory there is on my machine, how much memory it will allocate. And now it's analyzing my application and compiling it so it can produce this native executable in the end. What's interesting, I mean, there are a couple of extra classes that I don't need, but if you pay attention here, so in my application, that is basically just a few classes. So it analyzed my app and it saw what exactly from this app I need and what I just infrastructure things that I maybe don't need. So in terms of classes, actually 90% I'm actually using, that's not too bad. But when it comes to fields and methods, only 60% of them I'm effectively using in my app, and the rest can be just eliminated because I don't need them. This is something that my application will never use. But our build is done now. Also, it wasn't too bad. So 46 seconds, I would say it's quite okay considering it packaged everything that there is in my app. So let's run it now as a native app, target demo, and maybe I should kill that tab first before I do it. So if I run this, it started in 49 milliseconds now. And if we go back here to hello, it does the exact same thing. Only now it starts in 49 milliseconds, and previously it was, I think 1.1 seconds. So starts much faster and also using way less memory. So in my observation, this plain simple app uses around 70 megs of memory, so around 70 megabytes RSS, and I haven't tuned it in any way yet. So if I want to take this memory requirement even down, I can limit it even more, and it will still be functional and still ready to accept requests and do all the work that I have to do. And I like the way that Josh Long talks about those things. So he was showing a similar demo a couple of years ago with Alex Belgium, and he said, okay, this app is now using 100 megabytes. So how often it is that you deploy your Java application to production and you give it, let's say, 1 gig of memory? It's not that uncommon, right? So imagine if you can reduce that memory requirement to 100 megabytes, you can deploy 10 such applications of the footprint of that one or reduce your memory by 90%. That's pretty cool. Okay, so we have our plain Spring application, but let's see what else we can do. Let's say we want to keep expanding it. We have our web application as a base, but we want to add more cool stuff. Maybe we want to use some cool libraries. I don't know, have any of you used the Spring AI module yet? Okay, oh, somebody have. Okay, you can talk to me afterwards. I'm curious, how was your experience with it? So I want to also show you a Spring AI demo. Native Spring, where is it? AI? Yeah. And let's clear this. So this will be the app that we will be looking at. Okay, a lot of stuff. So this is my main application, and this app will be a travel recommendation kind of service where you can say, hey, I want to travel to that location, and this is the kind of activity I feel like doing, and I'm maybe in this mood. Give me some travel recommendations. And we have our controller here, and that is the prompt that we will send to the OpenAI API. And then what are we looking at? Now, this is the prompt that we will send, and we will get a response from OpenAI with our travel recommendation. And this is the controller where we are taking the input from a user. And for the sake of saving time, I already have it compiled as a native image, of course. So let's check it out, target. And I have my travel app here, and it's only 111 megabytes, not the smallest app in the world, but for having my app completely packaged with all the functionality, I think that's pretty cool. So let's run this one. Let's remove all of this maybe, and let's run it, target travel app. It started again pretty soon, pretty fast if you ask me. So let's go to localhost. can we also stop for a second and appreciate my amazing front-end skills? So I wrote all of this HTML, CSS. This might not look like much, but trust me, it's much better than it looked in the first iteration. So I'm very proud of this. So let's say you want to travel to Switzerland, because that's where I live. And it's Switzerland, so you got to be hiking, I'm afraid. And let's say we feel adventurous. So now our application will make a call to the OpenAI NPI. That's why maybe let's not read too much into the response times, because this is like a web call, basically. So it's mostly affected by the network connection. But here we have our travel recommendation. So it suggests that we go to Matterhorn in Zermatt, Switzerland. I would say it is a common popular destination in Switzerland. So I would say this recommendation is indeed legit. But just to prove to you that this is not, hard-coded in the app in any way, let's try something else maybe. So let's say we are in UK, and I hope this will be enough as an input, just two symbols. And let's say we are tired of hiking, so maybe we want to do cocktails, and we are feeling, I don't know, let's say even risky. Okay, so let's see where this leads us. London, UK. Okay, I guess we're in the right place. And even for the riskier experience, there are some additional tips of the things we can try and places we can go. And if any of you are local, you can tell me afterwards if you think those were like any good tips or not. So yes, this is a Spring AI app. I will not say that I'm a big Spring AI expert, but just to show you how this happens. So this is my Spring project. And I believe Spring AI is not GA yet, so you would need to pull it from the Spring repository. And here I'm just specifying a couple more things. So I want my app to be called Travel App, etc. Here's my native image configuration. And to make Spring AI happen, so yeah, you need access to Spring milestones, and you need to pull it from here. So this is how you can build such an app, and this has happened without any configuration. So this just works out of the box, including with GraalVM native image. So yes, I think this was a very cool app, and let me know how you like it afterwards. Let's go ahead with the presentation then. So I mentioned using cool libraries and building applications with GraalVM, and the question that I get when I talk about this a lot is, how do I work with libraries in GraalVM native image? How do I make sure that my library will work? Let's say I want to move an existing project to GraalVM and I have a set of dependencies. How do I verify that they work? Or maybe I'm deciding if I want to go with GraalVM. So how do I evaluate libraries and what is available to me? Because indeed, some things will require some extra work and input to be working with GraalVM in the native image mode. For that, we have this super helpful page on the GraalVM org website that is called Ready for GraalVM Native Image. And this is a list of libraries and frameworks that are known to be tested and continuously integrating with GraalVM. So the actual list might be much longer, but those are the ones that we know of, so the ones that have been reported by the community. And this is based on community contributions where people tell us, hey, we know that this library is testing with GraalVM. So this is not a complete list, but like a minimal list of libraries that work with GraalVM, and there are more such libraries out there. But as a first step, if you want to move your project to GraalVM, I would suggest that to evaluate dependencies, you go there and you check in this very, very long list of libraries and tools whether it's there, and then you know that it's for sure working with GraalVM. There are two levels of integration, kind of. So library can either ship the configuration within the library itself, and it's the preferred way to configure things for GraalVM, or a library can have configuration in what we call reachability repo. So this is the repo where it's a centralized place that we created for the community users, library maintainers, framework authors to contribute necessary configuration for GraalVM. And here, if you're using our native and native Maven and Gradle plugins, you can pull this configuration from this place to build apps with GraalVM. And let's talk about configuration, because this part is a bit, I don't know, like maybe tricky about GraalVM. So where does this come from, and where maybe some possible migration challenges are coming from? When I was talking about native image compilation, I mentioned that we are compiling applications ahead of time. So all that work that the JVM normally does at runtime, we are doing at build time. And to make this possible at build time, ahead of time, before the runtime has actually happened, the way native image analyzes your application is by applying a closed world assumption. So we are saying, hey, everything there is to know about your application needs to be known at build time. To compile ahead of time, we need to know everything about your app as we are building it before the runtime has happened. And this means that some of the more dynamic Java features, such as reflection, serialization, resources usage at runtime, etc., They work with GraalVM, but they require a little bit of configuration to be known and visible at build time. So how many of you have heard that GraalVM doesn't work with reflection? Still a lot of people, still a lot of work for me to be doing to kind of fight that misconception. So GraalVM works with reflection, but there are things to know. So the things to know are the following. When it comes to reflection, some of the more kind of predictable, obvious reflection calls, native image will figure out of the box. We have this detection mechanism. So if you're doing something a bit more trivial and predictable, native image will figure out by itself. You might not even notice that it happened. It just works. If you're doing something a bit more complicated that it's kind of hard to predict at build time rather than at runtime, you need to tell native image, for example, hey, I want to access at runtime this resource or this class using reflection. Please account for this and please include it as they are building the application. So native image will include it and it will be available at runtime. So you need to tell native image about those dynamic features and how you're planning to use them. And that happens in the form of JSON files. But writing JSON files, it's not very exciting. So luckily, there are better ways to do this. So this long, complicated slide, it's about how libraries and those dynamic Java features work with GraalVM. And this is going from the most optimistic scenario to a scenario where it requires a little bit more work from you. So let me walk you through this, because I get this libraries question a lot, so I want to address this. So the best possible scenario is that a library can be friendly towards GraalVM native image out of the box. So this is still a new thing, but we see new libraries sometimes appearing in a way that they are designed to be working friendly towards native image out of the box. So maybe they're not doing reflection, maybe they're doing functional configuration, but they just work out of the box without any config. That is the best possible scenario. Now, second best option is when the library knows that it's doing some reflection, serialization, etc., and it's shipping the config inside the library itself to tell native image and GraalVM that, hey, this is what I'll be doing in terms of reflection. Please account for this and please make this available. So the way this works, I want to illustrate this on the example of H2. I used to show this demo where I had an H2 application and it will break as I build it as a native image because it could not figure out configuration for H2, and that I could pull it from the reachability repo and it magically worked. But now I don't even need to do this anymore because this is the source of H2 itself. And if you go there, there is this reflect config JSON files. And this is the file coming, was in H2 itself, and it tells GraalVM native image, hey, all those things I want to access reflectively, please make them available. So for you as a user, this means that you are just pulling in H2 and it works with GraalVM as intended, no input needed from your side. So this is one good option. Another good option is this reachability repo that I already showed to you. And if you're using our native Maven and Gradle plugins, the ones that I mentioned before, coming from the GraalVM team, this config will be pulled automatically. So if you're using our plugins, or many frameworks are using our plugins under the hood, for example, you want to use Netty, and they will pull this config automatically. Again, no action needed from you as a user. This is another good scenario, and I would say that those three first bullet points, those will be most of the cases. This is the happy path, but also if you're building a new app right now, this will be most of the cases how libraries work with GraalVM. Now, let's get into a bit of more like shady area. Let's say none of this is working for you. So maybe you have a legacy application, or maybe you have some internal custom libraries that are not made friendly towards GraalVM yet. So what you can do then? If you are using one of the frameworks that works with GraalVM, so Spring Boot, Micronaut, Quarkus, Helidon, they all have some kind of support for generating those config files for native image programmatically from your app. This looks a bit complicated, but let's say I know that I will need to access app.properties, so I can create this runtime hints from within my app and say, hey, please include this. And this is for Spring Boot. So what this will do is the Spring AOT engine will create this config for me programmatically. I don't have to worry about it. It will just appear and make this file available for native image. Another helpful thing, let's say you are not using any of the compatible frameworks, libraries, things are not so good. So we have this great tracing agent in native image. And the way this works is that you can run your application on the JVM with the agent attached to it and apply a relevant workload to it. So let's say I want to make a certain endpoint available in the native image mode. So I will run my application on the JVM with the agent attached to it. It will see what I'm doing. It will detect, let's say, those reflection calls. and then it will output config files for me that native image can then pick up and include in the native image build. And the last step that I hope you will never have to get into, but just for the sake of giving you full information, so you can also provide such config manually. Let's say I only have one class that I want to access reflectively, so I can just say in my JSON file, hey, this is the class that I want to access, and I would need one field from it, so please make it visible. So this is maybe looks a bit scary and complicated, but I wanted to cover this topic of how you make libraries work with native image and GraalVM. And I do hope that in most cases you will stay within those first 3 bullet points, where all things just kind of magically work for you and you never need to go into any of the extra steps. Okay. And let's say we are building our application, we want to go to production with our app. So what are the things that we need to know about GraalVM, and what are some good development practices? How do I build and test and develop my application? So one thing is that luckily all those frameworks offer some kind of support for GraalVM for building applications and for testing them. And for example, this is on the example of JUnit, so you can specify specifically for some classes, methods, fields, if you want to test them in native image or not. So you have this more granular control over what gets tested in the native image mode specifically. Okay. And let's also talk about performance, because I work on a compiler, so that's one of my favorite topics. This is a bit of a spoiler, but do you think AOT compiled code can it be faster than JIT or not? So who thinks it can be faster? My VP thinks it can be faster because he knows that we are working on it, so of course he has to be optimistic, right? But yeah, it can be faster. And this is a bit of a new concept for the Java ecosystem, that you can compile things ahead of time and it can be faster than the JVM, because we all know and love the JVM and it's amazing at optimizing for peak performance. So we know how it works. It profiles the applications at runtime, it observes the application as it goes, and it can adapt on the go to specifically focus the compilation efforts on the hot parts of your application. So it seems like there is no way to beat it at that, because it happens at runtime and it just has more information available than GraalVM and native image. But it's a bit more complicated than that. So native image, as we see here on the example of this pre-pet clinic application, it can be on par or even slightly faster than the JVM. And native image has a bit more advantages than the JVM, or maybe slightly different advantages than the JVM. So one advantage is that native image compiles the application ahead of time, meaning it's not competing for the resources of your machine with your application. So it can spend the time and resources to optimize your application really well, because we are doing that at build time, so we're not taking anything away from the runtime. Second, I mentioned profiling and how the JVM uses the profile of your application to understand what is going on at runtime and where it makes sense to invest the compilation efforts. So there is this great optimization in native image, which is called profile guided optimization. And that means that you can build an instrumented binary of native image, so an instrumented version of your application, then run it and apply a relevant workload, and it will collect this profile information for you. And then we can feed this information back into native image, so that native image can build an optimized version of your app that is aware of the runtime behavior of your app that hasn't happened yet, because you collected it in the instrumented run. But this way, we can kind of combine the best of both worlds, where we can use the time and resources to optimize the application really well, but also we have an insight into the runtime behavior of your application because we collected those profile information. So this is really powerful, and along with some additional things, such as, for example, G1GC, you can achieve the results that we see here on the picture, where native image can be on par or even slightly faster than the JVM. But peak performance is not the only metric that we care about. I also like this slide and this chart. It takes a few seconds to parse it, I'll be honest with you, but stay with me, we can do it. So what we are measuring here, it's kind of memory efficiency. So we are mapping the operations per gigabyte per second, so how much throughput you can get per given amount of resources and time. Some people call this throughput density. So saying we have this amount of memory and we are using for this amount of time, how much throughput, how much valuable work can we get from it? And we map that onto XMax settings to see if you give your application more memory in terms of XMax, how does that help the efficient use of your resources? And the orange line here, that is native image, and the blue one, that is GraalVM with C2 JIT. So that's effectively your OpenJDK setup. And I see two interesting observations here. So one is native image is consistently over C2 in terms of utilizing memory to produce valuable work, because as we've seen, it can give you a comparable peak throughput, but it uses way less memory. So you will always get better efficiency with native image. And specifically for like, I would say smaller to medium heap sizes, so maybe around 512 to 1 gig, native image is twice as efficient as the JVM, because for those application sizes, it can utilize resources even better. So that's one observation that I would like you to take from this, is that if you want to get good value out of your infrastructure available to you, native image can definitely help you make that happen. And I will not stop a lot here, but even if you have things like SLA for, let's say, your latency, even for latency, you can get good results with GraalVM native image. There is no metric in terms of performance that you would need to sacrifice. Okay, and let's talk a bit about some tips, tricks, and good practices for building and deploying your applications. So if you want to have very small container sizes, it's definitely possible with native image. Here you can see various packaging kind of options with GraalVM and with different JDK distributions. The blue bars, that is still the JVM mode, and the orange ones, that is native image and different modes of packaging with native image. And with native image, here we are packaging JDK simple web server. So with native image, you can go to as little as 18 megs container image size. So if you want to have absolutely small packaging sizes, native image will help you with that. And also about this, I think on the first day, there was a very good talk from Sean Smith from the GraalVM team, where he talks a lot about packaging and linking and how that is good for compact container sizes, but also how it's a good thing for security. So go check that talk out when the recordings will be available. And also for packaging, I want to mention one more thing that I personally like a lot. So I mentioned that native image produces architecture and platform-specific native executables. And that's because we need some JDK-specific classes for each platform. So for example, if I'm a Mac user, I cannot build here on this machine a binary that will be for Linux and native executable. But you can easily use CI/CD systems for that. It can be a CI/CD system of your choice, or I personally like GitHub Actions a lot, especially lately in the last couple of years when they introduced really good runners. You can build even bigger applications on GitHub Actions. There's enough resources available, memory requirements, everything just works out for building native applications. And in the end, maybe I can even super quickly show you this. So if I go to my native Spring Boot repo, actions, okay, I think this was the last commit there. So I have this set up to build native executables for Ubuntu and macOS. And every time I have a new version of my application, it will just build those applications for me. So let's say if I want to give them to my users, I can do so. And GitHub Actions is a very good source for that. And we also have our own GraalVM GitHub Actions, so you can easily pull GraalVM builds and configure GraalVM builds for GitHub Actions specifically. So this is one thing I definitely would recommend. Now, I do want to mention a few things about security, because when you hear native image, most people mention fast startup times, some people mention packaging size, etc. But there is a very interesting security angle to native image as well. So we saw even in the demo that native image eliminates a lot of the code that you are not using. And this way we are reducing the attack surface, because things you are not actively using will be eliminated from your application. Also, there is no JIT compiler anymore. So some of the attack vectors that target the JIT compiler specifically, they are just not possible with native image, because in the end, it's all native code. There is no JIT compiler anymore. And then things like reflection and serialization, they require a specific allow list from your end, or maybe configured from the library, framework, etc. But there is a bit more control and awareness for you for what happens in your application, because unless you allow those things, they will not be available. And it might be seen as a limitation, but I think it's just a different architecture choice. And it enables more control and awareness of you of what happens in your application, and also makes your application more secure. Okay, and let's say you want to build your application with GraalVM. What are some good tips and recommendations that I would give to you? If you want to take one photo of the slides, I would suggest that you take a photo of this slide. So if you want to migrate an existing application to GraalVM, the first thing I would do, I would add native build tools. And native build tools, that is the Maven and Gradle plugins coming from the GraalVM team. And that will help you build your applications, test your applications, and also incorporate dependencies automatically, or rather incorporate config for your dependencies automatically in your project. Or if you are using recent versions of frameworks, so for example, Spring Boot starting with the version 3.0, native build tools will be included, so there is no extra steps needed from your side. And to evaluate libraries and their availability to you in the native image mode, you can also go to that Ready for Native Image page that I showed you on the website, and there you can see the libraries that are available to you. Now, for building, testing, and deploying, and we get also this question a lot. So how often should I build my application in native as I develop it, or maybe how often should I test in native image mode specifically? And our recommendation there is build and test your application on the JVM as you normally would, and then you build in native and test in native, maybe in your CI/CD, or eventually once in a while, maybe once a day, but you don't need to rebuild your application in native every time you're introducing a new change, especially if the change is around your business logic, because then it will definitely not break things. Just to be sure, test maybe in your CI/CD, or if you're introducing a new dependency and you want to make sure it works, or if you're attaching things that you know might be sensitive for native image, such as reflection and serialization. But overall, just build on the JVM and compile to native, maybe in your CI/CD, or let's say once a day. Now, small tip, but I like this one a lot. So as you're developing your application and you still want to rebuild in native and make sure things work, there is this very helpful -OB flag, and this enables quick build mode. This will not make your build like 10 times faster, but it will make the compilation step faster. So if you want to get results faster and just verify that your application still works, this -OB flag is very helpful. And yes, use CI/CD to deploy your application and also produce different versions of a native executable for different platforms. Now, in terms of performance and specifically for native image, so I mentioned PGO, where we collect profile information in advance and feed it to native image to have optimized version of your app. But this requires an extra step. So you can build your application instrumented, collect profile information, then rebuild it again with the profiles. And it gives you the best possible peak performance, but let's say it's not possible for you to do it. And it seems like predicting runtime behavior of your application is a good task for ML, which is all the trend now. And indeed it is. So if you are not doing PGO, what we call user-provided PGO, so if you're not collecting profiles yourself, we have the next best thing, and that is called ML PGO. So we have an ML model in native image that will look at your application, analyze what it's doing, and predict profiles. It will not be as precise as the actual profiles that you would collect yourself, but it will give you maybe 6-8% extra performance improvement over not having any performance at all. This is enabled out of the box, so this is not something you would have to enable yourself. Additional tips for performance. So G1 GC, there could be different GC strategies, but in our observations, specifically for peak throughput, G1 GC usually is the best one. And also, if you know that you are building your application on the machine that it will be running on, so not distributing to users, but running on the exact same machine, there is this MARC native flag that will target this native executable for that target machine and use all these specific hardware features of that machine, make the best use out of it. So those 4 flags are the best recipe for good peak performance with native image. Okay, and I want to talk about what's next for GraalVM. So recently we released our GraalVM for JDK 22. In terms of releases, we have the same release calendar as the JDK itself. So every time there is a new JDK release, there is also the new release of GraalVM on the exact same day. So you can use all the latest JDK features on the latest GraalVM features in one release. And talking about this, I want to show you 2 more demos that I have built specifically for this release. So let's go back here and let's clean this up a bit. Okay, and let's maybe start with this native modern Java. So let's go there, modern Java. And this application is original demo was developed by my colleague, Nikolai Parlog. Does anyone here know Nikolai? Yes, we all know and love Nikolai, right? So there is this modern Java app that he's been showing at conferences lately. And this is basically a GitHub crawler. So this app was created to showcase all the latest Java features. So virtual threads, web server, pattern matching, all the best practices and all the latest Java features. So Nikolai is showing this demo. It's really cool. And I thought that demo could be, improved even further by adding one more piece to it. So I forked it, and I have my own version of it, this one. Just let me go back here. So this is a fork of Nikolai's demo, and I wanted to port it to GraalVM, and the only thing I added there is basically one commit. So I extended the README, but whatever. And I added native Maven plugin. That's why I'm always saying, please add native build tools. So please add native Maven plugin. So I added that, and I basically just did two more things. So I enabled preview features because Nikolai is using preview features. And in GraalVM and native image, we also have this concept of preview features, just like on the JVM. So if you want to use preview features, please pass the flag so we understand that. And I specified the name. But the app itself is a GitHub crawler, and let me just move this higher up, and let me clear this. So I already have it again compiled for the sake of saving time. So it's here in my native modern Java. You can also appreciate the size, so it's 37 megabytes. But let's run it. So target native modern Java, and it's a GitHub crawler. So the whole point of application is that you give it a URL on GitHub, and it will go to that URL, identify all the links on the page, qualify them, what kind of link is that, and print out for us a nice little report. So we need to feed it a GitHub URL. So let's pull one of my favorite GitHub tickets that we have for the GraalVM team, and that is a big epic that we are working on, that is layered native images. So let's get this URL, let's feed it to our application, and we need to specify the desired crawl depths. And now let's hope neither me nor anyone else at the conference have abused the GitHub API today yet. So let's hope this works. Okay, it does. And it printed out this report for us, but it's not just that. It also created this beautiful little page. Let's go here, and you can also appreciate Nikolai's front-end skills. But this is my application running on GraalVM native image using all the latest Java features on the best practices, and it looks like this. So it works. It found all the links. It told me what kind of link is that. Is that external? Is that an issue? Is that a PR? And the whole application is just 37 megabytes. So that's pretty cool, I think. And thanks, Nikolai, for borrowing me this cool demo. And I want to show you one more app. So I talked a lot about using cool latest libraries with GraalVM. No, not that one. This one, native. So anyone used the LangChain4j yet? Okay, a few more people than Spring AI. Okay. So let's look at the app itself. Here is my app, which is a no-brainer app where we are taking an input from a user, and then we are going to talk to the OpenAI API and get a response to that input. And this is, of course, compiled already with GraalVM. So if I look here, where is it? 47 megabytes, slightly bigger, but it's a full-blown application. And it's not any framework, so this is just a plain Java, and it's working with GraalVM, out of the box, native, compiled, works like a charm. But let's give it a try. So let's run it, target native, and we need to give it an input, right? So let's do something. Hello. Okay, how can I assist you today? Let's ask it something. What is GraalVM? Could have been faster, but you know, internet connection. Okay, why is it taking so long? Maybe it's too complicated of a query, I don't know. Come on, this was working just this morning. Like one time I have my management in the room. Come on, let's try again. No. See, sometimes it's just randomness, right? But yeah, it says GraalVM is a high-performance runtime that provides significant improvements, blah, blah, blah. So yeah, it works. Let me give it like one more shot, because why not? So let's see if I got this. Who is Thomas? Okay, and now I need to really focus. So let's see if I got this. View Earthinger. Fingers crossed. Okay, don't let me down. Okay, Thomas is a senior research director at Oracle Labs, slightly outdated, but you know, was true at some point in the time. Project lead for GraalVM, blah, blah, blah. Okay, I think this is accurate enough. So again, as you can see, my app works in the native image mode, can use all the latest cool libraries, and it's all really awesome. Okay, let's head back to the slides. Yeah, it was demo. And I want to mention a few big things that are coming up next for GraalVM. We have two big ambitious projects that we are working on. One is called Layered Native Images, and that's the GitHub ticket that we've seen before. So if you ever try to build a bigger application with GraalVM and native image, you might have noticed that the build times can be a bit longer for a big app, and there is a lot of work to be done. So even for a trivial application, it's thousands of classes. So native image has a lot of work to be done at the build time. And we are aware of that. So we are now working on this concept of layered native images. And the idea there is that you will be able to define something that we call a base and compile that base ahead of time and have it compiled as a shared library. And then every time you're introducing changes to your application, you are only recompiling your application code, the code that you actually wrote, and that part stays compiled ahead of time. So every time you're introducing changes, you're only recompiling your own code, and it's much faster. It will be a matter of seconds because there is way less to recompile. And that's one benefit. So faster compilation, better developer experience. But there is another big benefit, and that is when you're deploying your application. Let's say I want to deploy, 5 instances of my Spring application or my Micronaut application. So I can have deployed my JDK base, my Spring base, and then those smaller instances, so the actual applications, can reuse those resources. And this way they can consume way less resources in the cloud. So we are very excited about this project. We are working on it actively. Expect more news in the future. And another big ambitious project, and I really like the name, GraalOS. So we are working on a new way of deploying your applications where you will not be deploying a container because we think that's an extra overhead in terms of time and effort, but you will be able to deploy your application as a native image, and then we will take care of the scalability, security, performance, allocating resources, all of that for you. And Eric was talking about GraalOS on day 1, so you can also find that talk on YouTube and see more and even see some first results of how this is working in practice. Okay, so to summarize, what GraalVM gives you and what you can get from it is fast startup, as all we've seen, but also lower resources usage, specifically lower memory and CPU usage. You can also have a much more predictable performance from the very first milliseconds. Your application is immediately available. There is no warm-up curve. It adds additional layer of security on top of your JDK deployments. You can have much smaller packaging size, and there are a lot of libraries, tools, and frameworks out there to help you build your application with GraalVM native image. To get started with GraalVM, you can go to our website or you can use SDK-Man. We all know and love SDK-Man, right, to pull the latest version of GraalVM and just started using it already. And if you want to try more demos, now it's time for a lot of QR codes. You can ask me any kind of question on Twitter. And if you want to pull the demos that I have showed here today, this is my GitHub page where you can get all the demos. I see that people are taking the photos, so I will give you another second. And the last QR code for today, please rate this session. It was great talking to you. And if you have any kind of question or feedback, please come here to me and I'll be happy to talk to you. Thank you so much for coming.